Hello and welcome to Minerals, Rocks, and Fossil Talks. I'm your geology teacher, Jen, and it's time for Field Trip Friday. We are out at Strawberry Reservoir. You can't see the reservoir because we're in the middle of a road cut, but I promise you there's a very large reservoir behind me. But we're not here to look at water, we're here to look at rocks. So, let's look at some rocks. Alright, so right here we have a very small outcrop of the Uinta Formation, which is one of the formations that you can find Uintatherium in. And if you don't know what Uintatherium is, check out yesterday's video. I talked all about it. It's a pretty cool looking animal. It's a mammal. But let's talk about this rock because it's super cool. First off, you'll notice that there are pebbles embedded in this, and it's kind of layered a bit. This is a channel sandstone. What that means is that this used to be a riverbed. So at one point there was, I'm sliding down the mountain. Thank you.
I got you.
It's very loose stuff, guys. This is very well eroded. But this meant that there was a river that came through here back during the Eocene epoch. About 48 to 37 million years ago. And it's very possible that a Uintatherium drank from this river at some point. It should be super cool. You'll see there's other layers as well, if I can get up. So there's another layer here. So this is a separate layer. If I chunk off a piece, we can figure out what kind. Okay, this looks more like mudstone or siltstone, muddy siltstone, silty mudstone, somewhere in that vicinity. So this would have been probably either the edges, the creek, river, could have been the floodplain around the river. We got another layer up here. Already looks a little bit rougher. Ooh, big chunk. Oh, this is sandstone. I already tell you, you can kind of see. You can see that. So there's more sand. So another place where there would have been river or another channel coming through. So we can see a little bit of change over time, which is super cool. So how do I tell the difference between all of these layers other than, they're stacked on top of each other? Well, let's take a look real quick. We good? Okay. So here's my chunk of sandstone. Here is my chunk of muddy siltstone or silty mudstone. Right now, visibly, and because I've got a non-geologist with me, do these look different?
Not really. They look pretty similar to me.
Yeah. We have the same color and what looks like very similar textures. Okay. Now, I showed it up close. You can actually see the individual grains here. If I run my hand over it, and I know through the video it's hard to see, it feels very, very rough and gritty, like sandpaper. That's how I know this is a sandstone. Another option I could do, which I'm not going to do because I just broke this off. I know this is the fresh surface, but I don't want to. Well, hold on. Okay. What I can do is I can take this, and I can chew on it a little bit. And, yep, tastes like sand. It's gritty in my mouth as well. So if it's gritty on my fingers and gritty in my mouth, then you know that it's a sandstone. Okay. Now with this one, if you look up close, it's a little harder to see. It's still a little, I'm going to go with siltstone on this. It's still a little gritty, but it's nowhere near as gritty as my siltstone or sandstone. And if I were to chew on a little piece of this, Yeah, it's not sandy per se. It's still gritty. But I don't feel like I'm going to get grains of sand stuck in my teeth chewing on that. If it were a mudstone, it would have a sort of chocolatey consistency. I know, it sounds really weird, guys, but it would be very smooth and not gritty at all. The channel we've got down below, because we can see the pebbles in it, it's technically a conglomerate. I don't have to put that one in my mouth because I can see the good sized pebbles in there and I know that's a conglomerate. But yeah, so we can kind of see, and the reason it's red is probably due to iron. So this stuff would have been oxidized. There would have been a high oxygen content during this time period, which makes sense because during the Eocene we were during our thermal maximum, and it was very much like a rainforest in North America at the time. So there would have been a lot of oxygen being produced by all of the plants that existed here at the time. So it would make sense that a lot of the stuff that comes out of this time period are red. And unfortunately, because the other side of the road cut is also a very big hill, I can't show you, well, actually. Okay. I'm gonna go behind my husband. The far hill, I don't know if you can really tell, but the far hill is Green River Formation, which would have come after. And it is also red in this area. But yeah, now you know a little bit about the Uinta Formation and even less about the Green River. We'll get into that one again later because there are some really, really cool outcrops of the Green River Formation in, gee, I don't know if it's technically Spanish Fork Canyon or Price Canyon because they kind of meet together in the Green River Formation. So either or. At some point, we'll end up that way because I have to take that canyon to go visit my aunt and my grandparents, and so you'll see it at some point, promise. But yeah, hope you had fun on this field trip, and I will fossilise you later.